Apple's long-awaited Genmoji feature, which allows you to create any emoji based on a prompt, has finally released after months, if not years, of development. But I think I can do better. Here's how I remade Genmoji in one day. And little did I know, this project would lead me to eventually completely reverse engineering Genmoji, revealing secrets about how Apple made it so good. The plan, at least in theory, was pretty simple. I would take all of the emojis that Apple has available and, using it as training data, fine-tune an image generation model, which just means to force it to look at thousands of emojis until it knows how to make them in Apple style. Then, after I have an output emoji, the best part is that using iOS stickers, you'll actually be able to use it just like you use an emoji. But as it turns out, replicating a flagship Apple Intelligence feature wouldn't be as easy as I thought. The first step was to obtain data for fine-tuning. Since we're essentially teaching a model to create an emoji based on a prompt, the training data would need to be in pairs of prompts and output emojis. In our case, the emoji name and the image of an emoji. Now, while the entire list of Apple emojis was right in front of me in the emoji menu, getting to the images and names of them was a bit of a headache. On macOS, emojis are part of a special font file, and while it is possible to convert the emojis in a font file to PNG, I didn't have access to their names, which defeated the entire purpose of getting them in the first place. So instead, I turned to my best friend, the internet, for some help. After going through some emoji catalog websites, I settled on Emojograph. Inspecting their Apple emoji list conveniently revealed the name and link to each one of the 3,770 emojis available. However, since I needed to download each emoji with a separate web request and I didn't want to overwhelm Emojograph with nearly 4,000 requests, I decided to remove the skin color variants for the emojis, cutting down the total by almost half. This forces the model to generate skin tones in a standard bright yellow, but in the end, it wasn't too big of an issue. With all that decided, I then painstakingly wrote some Python code and put the names and links of each desired emoji into a JSON, adjusting the link route for each one to get the full resolution 160 by 160 emoji image. Now, one issue is that all of these emoji images have transparent backgrounds, while current image models don't really work well with them. But it's a pretty simple fix. We can give the emojis in the training data white backgrounds. This would in turn cause the output emoji to have a white background, but that's nothing that can't be fixed with a simple background removing script. And this method is actually quite fitting, since it's exactly what Apple Genmoji does. How do I know? If you look closely at Apple Genmoji on a dark background, it's clear that there's a white border around the emoji itself. That's the residue from the final background removal step. Fun fact, that's why in nearly all of Apple Genmoji's marketing videos, they choose to use a perfectly white background. So with that knowledge, we just have to write a Python script to download the emojis, give them a white background, and put it all into the image model training format. That is, a folder with pairs of images and prompt files, in our case, the image of the emoji and the name of the emoji. With training data obtained, next up was to do the actual training. The model we'll be using is Flux1 Dev, which is an extremely capable image model with open weights, though it is worth noting that it is non-commercial, unlike its sibling model Flux1 Schnell, which is Apache. Then I used a tool known as Simple Tuner, which made fine-tuning extremely simple. All I had to do was modify a few config files and run a script. For our training, we're going to run it for a total of 10,000 steps. And then we wait for it to train. Now, something interesting is that while training, I had it generate 2 images every 100 steps. First, a sample emoji of a smiley, and second, an unconditional image. Essentially, unconditional means having it generate an image with no prompt at all. And the results were pretty interesting. Take a look. Now, for the actual training itself, I'm currently running a 40-core GPU M4 Max MacBook Pro with 64GB of RAM. Letting it run without any interference, it can do about 3 to 4 seconds per step, though the GPU was literally boiling at around 100 degrees Celsius the entire time. After nearly 10 hours, I was extremely happy to hear the fans on my MacBook stop blowing at 8,000 RPM, but also pretty happy to know that training was done. So I tried a simple prompt, flying pig emoji. And to be honest, I was a bit disappointed. Sure, it was a pig on a white background, but it was hardly an emoji. For one, its features weren't exaggerated like an emoji should be to be visible at a small scale, and furthermore, the emoji was, for the lack of a better word, not very Apple. So I tried another prompt, and another. And disappointment followed disappointment. And I almost thought that these 10 hours of training went to waste. But I'm not one that's quick to quit. I had one last trick up my sleeve. You see, I had a hunch that the issue with my emoji was that the prompt was not descriptive enough. And what better place to find a prompt than from Apple itself? After all, I'm no stranger with messing around with the internal system prompts for Apple Intelligence, and I sure am not afraid to do it again. Looking at the system assets directory where all the prompts are stored, there were two folders, one for visual models like Genmoji and another for language models like writing tools. Looking through the visual folders, I was disappointed to find, well, nearly nothing. All Apple had in there was a template that said a emoji of prompt and a few things that managed skin color and appearance. It appeared that each appearance had its own keyword that triggered it, and given the time and budget that Apple has, I wouldn't be surprised if each appearance also had its own fine-tuned model too. Either way, interestingly enough, if you put the exact keywords as seen in the JSON into Genmoji input, it will simply refuse the prompt. But this knowledge about skin color and appearance was literally the least useful thing I could have found, since about 10 hours ago I decided to remove that very thing from the training data. And at this point, I was actually lost. But I still had one last place to check. In fact, I had a sneaking suspicion about something that would be confirmed in that very place, the language model folder. You see, image models such as Flux have limited understanding of the prompt that it's given. While it probably can pull words or phrases here and there to make the image, a 2-word description of an emoji like flying pig wasn't going to cut it, since in simple terms it didn't really know what a flying pig is. Meanwhile, something like an LLM would be able to understand these 2 words better and perhaps make more out of it. But if that's the case, why not have an LLM take these words, transform it into a more descriptive prompt, and then give it to Flux? So based on this logic, I looked into the language model folder for Apple Intelligence. And I actually did find one mention of emoji. And that one single mention was enough to confirm my suspicions. All it simply read was, rephrase this text. So I got to work, holding on to the hope that by making my prompt more specific, it could change everything. I started by manually elaborating on my existing prompt, and after almost an hour of tedious prompt engineering, I managed to get a prompt that worked extremely well. The change was incredible pre- and post-prompt engineering. And with that newfound knowledge about the importance of prompting, I started working on a meta prompt for a LLM to generate the prompt for Flux. And again, after much fiddling around, I ended up with this. And I completely respect if you don't want to read this giant document, since I wouldn't want to either. Essentially, we start by telling the LLM to describe everything about the emoji in detail. Furthermore, I noticed a few things about the way that Apple generates its emojis. For example, whenever animals or humans are generated, they are always looking at the camera. And most of the time, animals have comically large heads. So I told the model to add these descriptions and also a few more when appropriate. And with all of that, I present to you Open Genmoji, the same process and technology that powers Apple Genmoji, remade with open software. It turned out that the trick to Apple's emoji generator was a good prompt, and specifically an LLM that helped rephrase your prompt so that the image model can understand it better. Now the best part about all of this is that you can use these generated images as actual emojis. All you have to do is slightly resize it with anti-aliasing to 800 by 800, save it to your photo library, and then make a sticker out of it. Now you can send the sticker like a normal emoji in iOS 18 and above. And now here's a few cool emojis that I tried out with my generator. And honestly, my implementation didn't do significantly worse than Apple's own Genmoji implementation. This project would not have been possible without the work of various amazing open source repositories, including Simple Tuner and mFlux. A huge thank you to all of the contributors on those projects. If you want to run or even train Open Genmoji yourself, all code and the fine-tuned LoRa are available on github.com/evanjodev/opengenmoji. There's comprehensive documentation to both run and fine-tune Open Genmoji yourself, so I highly recommend checking it out. And yes, before we end, I do realize I've essentially raised the requirement for Genmoji from Apple Silicon to a computer with a top-tier graphics card, which is arguably more expensive. But hey, at least it's not restricted to Apple devices only.